Hi, and welcome to the first of many demo videos introducing this new UK electrical simulator web-based application designed especially for aspiring trainee electricians. This simulator is a hands-on domestic electrical training environment built to help learners design, build, test, and understand electrical installations inside a safe digital workspace. Rather than only studying diagrams on paper, you can create realistic domestic circuits on screen, place real-world components, connect them together, and see how the installation behaves as you build it. At its core, the simulator is designed for UK domestic electrical design, wiring practice, fault finding, testing, and reporting. It allows you to add key components such as a DNO supply, consumer unit, ceiling roses, lamps, switches, sockets, and much more. As those components are placed into the workspace, you can wire them together, route conductors neatly, and build realistic training boards and circuits step by step. What makes this simulator especially useful is that it goes far beyond simple drawing. It also supports interactive testing and analysis. You can inspect circuits, use trace wire mode for controlled routing, measure voltage across components, measure current through conductors, and test resistance end to end. In other words, this is not just a drawing canvas. It is a practical learning environment designed to help you understand how installations actually work. The app has been laid out to feel clear, practical, and familiar. Across the top, you have the main navigation bar with a range of drop-down options. On the left-hand side is the component palette, and this is where the practical work begins. The first buttons give you the main building blocks of the installation, such as the consumer unit and DNO supply. Beneath those are common domestic components, including a ceiling rose, lamp, many types of switches, a fused spur, plus many more. This sidebar is essentially your toolbox. You select a component here, then place it into the main workspace. The main grid area is the workspace itself. This is the large canvas where your circuits are built. Components are placed visually, wires are routed between terminals, power can be energized, and you can quickly see whether you have successfully created a working circuit. Without going into too much detail in this first video, let's build a simple lighting circuit. We begin by adding a consumer unit to the workspace. To do that, click the Consumer Unit button on the left. This will place a DNO supply, which is our true source of power, along with a consumer unit containing 5 configurable RCBOs, bonding for water and gas, and a useful circuit meter. We will look at those parts in more detail in future videos. For now, let's keep things simple and add a ceiling rose. Click the Ceiling Rose button and a floating component will appear, following your mouse. Move it to a clear position on the workspace and left-click to place it. You can add as many of these components as you like, but for this example, we will just use one. To remove the floating component, either press Escape on your keyboard or deselect the button on the left. Next, we will add a one-way switch. Click the one-way switch button, choose a suitable location, place the switch into the workspace, and then deselect the button. Do not worry if you accidentally add too many components. Simply click the unwanted component and press Delete on your keyboard. To move a component, click it once until it changes color, then drag it to where you want it on the workspace. Click anywhere away from the component and it will return to its normal state. Once you are happy with the layout of your components, the next step is to wire them up. In this example, we will wire directly back to the consumer unit, although in future videos I will show you a much cleaner method that avoids lots of cables returning all the way back to the board. Let's start with the line conductor from circuit 5, which is the 6 amp RCBO, ideal for a lighting circuit. Hover your mouse over terminal L5, left-click, and begin moving in the direction you want the wire to run. You will see a dashed wire appear on screen, along with faint dashed guidelines to help you line up the route and change direction neatly. When you reach the point where you want the wire to turn a corner, line up the guideline, left-click, and continue moving towards the destination terminal. Repeat that process until you reach the terminal you want to connect to. In this case, that will be terminal L1 on the ceiling rose loop. Once you click the terminal, the brown wire will be created. You can then make small adjustments to the wire route using the corner control points. Repeat the same process for the neutral and earth conductors. Connect N5 to N2 and E5 to E. Next, we connect the light switch to the ceiling rose. Connect the COM terminal on the switch to L3 on the ceiling rose loop, then connect L1 on the switch to switch line 1 on the ceiling rose. You'll notice that the conductor running from L1 to SW1 is shown in blue, but with brown sleeving applied. That's because it is being used as a switch line. So although the core itself is blue, the brown sleeving identifies it correctly as a live conductor. The final step is to connect the earth terminal on the switch to the earth terminal on the ceiling rose. Once all three conductors are connected, enable the RCBO with a mouse click. It will turn white. Then switch the lighting circuit on, and you will see the switch button will turn green. You will also see the lamp change color, showing that the circuit is now live. Press the light switch a few times, and you will see the lamp turn on and off as expected. In the circuit meter, you can also see current flowing, in this example, around 0.09 amps for a 20-watt lamp. To make the circuit even easier to understand, press the A button on the consumer unit. This enables an animated view of current flow, helping you visualize how power travels from the line conductor through the lamp and back along the neutral conductor. Of course, this is not exactly how AC current behaves in real life, but it is a very helpful way of picturing a live circuit during training. Try operating the light switch on and off, and you will see the flow stop and start as the switch opens and closes. However, in a real-world installation, especially in domestic properties, we would not normally run individual wires between components. Instead, we usually use cables, such as 2-core and CPC, more commonly known as twin and earth. To help you plan your installation, select the Resources drop-down menu at the top of the screen, then choose Cable Report. This opens the Cable Predictor window, which shows the types of wires used throughout your design, and also provides a summary of the cable sizes and approximate lengths required. We'll cover wire lengths, cable sizing, and how to configure them in more detail in a future video. I hope you enjoyed this first look at the simulator. Please like, subscribe, and leave a comment below. The app is not live just yet, as it is still in development, but I would really love to hear your thoughts on whether this would be a useful tool in your training journey towards becoming a UK electrician.